So if you are in a school or college, if you are business school or college, so how Six Sigma will help them? So there is some case studies that the last happened. In the recent survey, it was found that around 89% of employer has preferred Six Sigma certified, that's maybe the black belt or green belt level of the candidate. They are just MBA. And this is what the example I have seen in my couple of industries as well, where I work. Whenever we are hiring any of the person who are coming of a fresh MBA from the college, we expect them that they should be familiar with the Six Sigma, or at least they should be Six Sigma green belt trained people. I'm not sure how they will certify themselves, but trained people, that is what our expectation is. When you are talking about an employer, maybe I'm the employer or you are the employer, you are hiring some of the entries, lateral entry or fresh entry people. So how Six Sigma help as an employer to you to improve your sales and revenue, profit, and also provide quality and customer satisfaction. So Six Sigma is built off of such a tools and techniques that will help you in terms of the customer satisfaction. Six Sigma will help you to improve the revenue. Six Sigma will help you to improve the profit, and ultimately, yes, it's the quality, and finally it's improving the customer satisfaction. Once your customers are satisfied, probably the chances of growing the business are much higher than the unsatisfied customer, because there is a thing that once you have a satisfied customer, so if customer is happy, probably they will tell to one or two only, yes, this company something is good. But if customer is on unhappy, if you have seen in the market, the unhappy customer will tell to the 10 people, or they will do the negative marketing for you. So Six Sigma is something that will help everyone to understand their business and to grow their business, right? So in this term, the Six Sigma is very much helpful to improve the productivity, quality, and ultimately customer satisfaction. If you are an employee or maybe you are an student, so Six Sigma will help you to better career, new job opportunities, like as generally the target audience we are targeting. So they all are, I'll say they are employee, they are working somewhere. So better career, new job opportunities, progression in current job, and the recognition at the workplace. So once you are trained in Six Sigma, probably your thought that will be different from the other people, because you understand what is the language of business and what is the language of Six Sigma. You will mix both of them, and you will finally come up with a bigger picture of how to grow the business, or how to improve your maybe any of the metrics like as productivity, quality, delivery, cost, or service. And Six Sigma provide you better skill set for the problem solving. So how Six Sigma is going to benefit you? I just classified into three factors. One, if you are a business school or college. When you are an employer, you are running an organization. And third one, if you are an employee or you are an student. So how Six Sigma helps you? This is what I was telling you in the last, I think at the time slide was not moving. So if you are an employee or an student, this is what our target is. The audience we are targeting, the third number. So this will give you the better career opportunities, new job opportunities, progression in the current job, that the promotion and all, and recognition at the workplace, because you understand better than the other audience, right? You are a Six Sigma trained people. You understand what Six Sigma is, what are the tools and techniques we use in Six Sigma, what is the methodology we follow in Six Sigma, and how these methodology, tools, and techniques helps you to improve the process performance. You will have, when you are a trained Six Sigma green belt or black belt, then it will help you to improve your skill set in problem solving, data analysis, and process analysis. Six Sigma helps you for the creative thinking and the process improvement skills as well. Now what is Six Sigma? So basically Six Sigma, that is a symbol of standard deviation or sigma that derived from the Greek alphabet. It's the sixth letter of the Greek alphabet. So if I just ask you as an audience, so what is good? You will say, I'll give you some example. Maybe you are running at the 60% of the output. You are at 80%, 90%, 95%, 99%, or 99.9% correct. And obviously you will choose that 99% is what is the best out of this. If 99% is good, 99.99% is good, this means if 99.9% is good quality, then even in a country like USA, it would have. These are some example based on the historical data that we prepared. So one, that's the 1 hour of unsafe drinking water every month. So at least you have the 30 days in a month. Out of 30 days, if you are running water out of 30 days, at least 1 hour will be that while the 99.9% good will be unsafe drinking water. Another example, if unsafe plane landing per day at ORA International Airport in Chicago. So maybe whatever the volume is there for the unsafe landing, that's the total landing or takeoff. So at least 2 unsafe landing will be there. So I don't think that any of us will be able to bear that, any of the unsafe landing. Another like a 16,000 pieces of mail lost by US Postal Service every hour. If it is 99.9%, there will be around 500 incorrect surgical operation per week at 99.9% quality, or 50 newborn babies that is dropped at the birth by the doctors each day in 99.9. 22,000 checks deducted from the wrong bank account each hour, and around 32,000 missed heartbeats per person per year. This is what the meaning of 99.9% of the quality. So still can we believe at the 99.9%? I'll say no. We cannot believe. So now Six Sigma will help you to achieve the Sigma level 6 performance. This means Six Sigma means you will have a chance of missing only 3.4 ppm. ppm stands for parts per million, means out of a million, if you are doing 1 million or 10 lakh of transaction, maximum wrong thing can happen, that is only 3.4 in a million. So in this case, the Six Sigma is a methodology for pursuing the continuous improvement in customer satisfaction and profit that goes beyond defect reduction and emphasize business process improvement. So in Six Sigma, we focus on defect prevention, not the defect reduction. We always identify these are the area or these are the sources of variation, sources of defect. We try to eliminate those sources of defect, so we work on the defect prevention. So Six Sigma or quality is the need of business. I'm at slide number 4. Six Sigma or quality is need of business. So there is 2 approaches basically that quality we ensure yes we are meeting the quality. Approach 1, that is the certification base, like a certification we have for the ISO certification, COPC certification, or maybe TS certification, or 14,000, 18,000 or TS 1649 certification like this. These are the generally this based on the audit checklist. Externally validated, some of the certifying agencies are there, and focus of this certification based quality is focus on the adherence of the documentation or adherence of the standards. While there is another quality, that means continuous improvement based quality, that is believe in striving for excellence at a moving target. If we are running production continuously, so my quality, I should be able to meet my quality requirement. Another, there is no need for the external validation, and documentation is just a part of the outcome of an improvement initiative. Say for example, if you are working on a Six Sigma project and we are preparing a case study of what we have done, what are the benefits we have done and how did we realize, that will be the documentation for this. Some of the example like a Six Sigma we implement, Lean we implement, theory of constraint we implement, business process re-engineering we do, or total quality management will do. These are the continuous improvement based methodology. So here Six Sigma comes for the continuous improvement based, not for the certification based quality. Moving to the next slides. So how Six Sigma basically started? So there is a little history behind Six Sigma. Actually in 1986, then Motorola started Six Sigma initiative, and there was a person, Bill Smith was the CEO of Motorola, who has started this Six Sigma. And the first team of professional implementing Six Sigma in Motorola that were karate belts. Hence, the term black belts, green belts came into the picture. So people used to be a Six Sigma. They used to be karate, green belt, or black belt, or master black belt, and these were the people who trained in Motorola initially. So that's why the same belts continue, but belts change from karate belt to knowledge-based Six Sigma belts. In around 2001, Motorola saves around 16 billion of cumulatively amount that they have dollars saved. In 1995, Mr. Jack Welch initiated Six Sigma in the GE. So basically, Motorola is the company who started Six Sigma, but GE was the company who commercialized Six Sigma. 1998 Allied Signal saved around 0.5 billion out of Six Sigma methodology only. Then 2000 G came with the 2 billion of annual saving approximately with the help of Six Sigma tools and techniques. Then Motorola initiated Six Sigma for process improvement, thereby reducing defect to the negligible levels. So Motorola initiated the project when the company was not doing too well with the customer satisfaction level as well. And it was Six Sigma was used to improve the entire business system. So actually G is the company, and after 2000 they commercialized Six Sigma, and then the Six Sigma came into the picture, or came into everyone knowledge. So what is the meaning of Six Sigma basically? So the term Six Sigma used to designate the distribution or spread about the average or mean for any process or procedure. So average or mean is same that we generally denote by the X bar, but when we call average, when we call mean, there is a catch here. So mean means when we are talking the simple average of the population. Population is the entire set of data, and if we are taking a small part of that population, that will be called as a sample. So when we are taking an X bar, that is average of the population, it is called as a mean. When we are taking average of the sample data, X bar of the sample data, that is called as an average. This is the difference. So for the process and sigma capability Z value, that is my sigma level, or another words we call process capability in form of CP and CPK. That is process capability and process capability index, is the matrix that indicates how well that process is performing. The higher the sigma capability, the better the sigma capability measure. And the capability of the process to produce defect-free outputs means as I increase my process capability, generally CP, CPK start from 0 and ends up to 2. Process capability C or CPK is, if it is 2, this means my sigma level is 6, my process is performing at 99.9997% good. Or same goes with the Z level. So Z value start from 0 to 6. If my sigma level is 2, sigma level is 6, means my process capability is 2, or my yield will be 99.9997% good. So a defect is, or what is the definition of defect? A defect is anything that's result into the customer dissatisfaction. It will result to the customer dissatisfaction only when I am not meeting the customer expectation or my output expectations. So what it is based on? Customer, anyone who is the customer, anyone who receive product, service or information, or who is using your product, service. Opportunity is a definition that generally we use for the DPMO calculation, is chance to do something either right or wrong. If anything, maybe I am doing any of the work, and this particular work may fail in 5 or 6 different things. So each out of these 5 or 6 will be an opportunity. So that is called opportunity. And defects, what is the success versus defect? Every result of an opportunity either meets the customer specification or it does not meet. If it is meeting, this means it's a success. If it is not meeting, this means it's a defect. So I have some expectation. I have a prototype of any of the process, any of the product when I'm going to buy or I'm going to use. This product should be like this, then only I will be happy. So if that prototype is meeting my real expectation or not, if it is yes, my product is successful. If it is not, means my product has got some defect. Moving to next slide. Goal and strategy of Six Sigma. So Six Sigma, basically we start from the variation reduction. From variation reduction, we go for the defect reduction. Then yield improvement. Ultimately it will improve the customer satisfaction and higher net income. So Six Sigma strategy that know what's important to the customer, reduces defect, reduce variation and center around the target. Or strategy that we follow in any of the Six Sigma, that is called as Y is equal to Fx. So basically two things. One is called as a methodology of Six Sigma. Second is the strategy of Six Sigma. When we talk about the methodology, we follow DMAC, that stands for define, measure, analyze, improve and control. These are the 5 stages of any of the Six Sigma project. And strategy that we follow is equal to Y is equal to Fx. Y is that your output, F is a function and X is your input. So output is a function of your input, or simply simple word, whatever the changes you are doing or changes are happening in your X, that is your input, that will reflect or that will impact your Y, that means your output. Next slide. So what do you mean by Six Sigma Y is equal to F thinking? So Y is a dependent variable. It is an output or effect, and it gives you the symptom if something wrong is happening in your process, and we can only monitor Y. While X is an independent input process, it's the reason behind the Y is changing, and these are the problem, not the symptom, and these can be controlled while your Y can only be monitored. Next slides I'm moving. These are the roadmap of Six Sigma. These are the major steps that you follow to complete any of the Six Sigma project. We start from first, we will select the CTQ. Then selecting CTQ stands for critical to quality. Critical to quality may be in any form of that generally metrics we follow is the productivity is one of the CTQ, quality may be the CTQ, cost may be the CTQ, delivery may be the CTQ. Any of the things that ultimately output that you are looking for and that you are not meeting, that is not coming within your expectation, will become your CTQ when you start a project. Then we will define the performance standard. Performance standard means what is my specification limit, lower specification limit, what is my upper specification limit for particular CTQ, what is my target value for that CTQ, and how much is the variation I can tolerate in terms of standard deviation or variance. Then from where my data is coming, then we'll validate our measurement system. The measurement system is of two types. One is your continuous type of measurement system and another one is a discrete type of measurement system. So measurement system analysis is also called as a gauge R&R. Once we have done, so then we'll see if my measurement system is valid. My measurement system is as per what standard I am looking for, like as for the continuous type of data. My total gauge R&R should be less than 10% and number of distinct categories should be more than 4. If I'm meeting that expectation, means my measurement system is good. Then we collect the data and we establish the process capability for the Y. The process capability we can establish in form of CP or CPK, or we can do even in form of Z value. Once we have done the process capability, we define our performance objective is what this is my current, because process capability is my current baseline I have done, then what should be the target based on that. So that is what I define the performance objective where we want to reach. Once we have done this, then we'll do the analysis. Here basically the tools will start. That is first tool we will use for the cause and effect diagram to identify the sources of variation. So what I will do, I will identify all these axes against my Y. So Y is my output and X's are my input. So I will make a cause and effect diagram. Then out of this I will do any of the analysis. Either I will go for the statistical analysis of all the data is available. That is hypothesis testing we do. Or other than hypothesis testing, there is some other subjective tools and techniques are also available that also can be used for screen the potential causes. Once we have done screening of potential causes, then we'll discover the relationship that we'll do from the Y is equal to Fx. We'll make a process performance model here and we'll see like a regression is one, that Y is equal to A plus Bx is the intercept and slope wala part is come. So we'll do when your X and Y both are continuous in nature. Once we have done that, we have discovered the relationship, we will establish the operating tolerance up to what level we can reach. Again, once we have done the improvement based on the whatever the access we identified, what the level of access we identified, we'll validate measurement system again. Either whatever the changes I have done, the data I am collecting is coming in the right way or not. If yes, my measurement system is valid, again I need to calculate post-improvement process capability. So my before process capability that I have done in the step number 4 and I am doing in the step number 11, that should be improved, or my process capability should be higher than the step number 4. That's why, and I will validate this statistically, yes, I have improved my process. Then I will go for the process control systems, or I will implement the controls that again I should not fall to the level from where I have started. This is how the Six Sigma journey will go, and there is a many thing in this Six Sigma journey that in all these 5 processes, these are many multiple tools are available. Say for example, in the define phase only, one of the important factor is the charter, project charter. We start from the identifying from the voice of business, then we'll go for the voice of customer, then finally we'll reach to the voice of process, and with voice of process we convert to the CTQ and we'll start a project. Then based on the CTQ we'll write our problem statement. Once we have the problem statement, we'll set our goal statement, we'll find out what is in scope, what is not in scope, we'll develop a team charter, we'll develop a roadmap, and we'll write a business case. Once my project charter is ready, we'll make a communication plan, army chart, RESIC chart, and stakeholder analysis. These are all the things that we do in define phase. In measure phase, basically we calculate the process capability, Z value. We do our measurement system analysis. If data is continuous in nature, we'll do the continuous type of analysis. If data is discrete in nature, then we'll go for the discrete type of analysis. And we will, after validating the measurement system, we'll calculate the process capability. Again, it depends on the data type. My data is normal or data is not normal. Then if it is not normal, the what type of distribution is the binomial, it's Poisson, it's exponential, and all that we have to understand. Then once the measurement system is done, then I will identify what are the causes of failure. Multiple access may be there. Then I'll make a statistical validation plan against each causes and will analyze by the hypothesis testing. There is a multiple tools like a 7QC tool also we can use, 7 management tools we can use for the analyzing of data. So it will depend on what is my type of data and what will be the right set of tool that I can use here. Once we have done the analysis, maybe I identified some X factors, that is maybe in numbers it is 10. But when I'll go for the improve phase, after analyze phase, I'll find out of 10 only 5 factors or 4 factors that has a significant relationship with the output. That is why. So what I will do, I will start improving only those 4 or 5 factors in the improve phase. Then post improvement, I will again validate my pre and post relationship. Pre and post validation I will do. What was the before? What is my after output is coming. If it is improved and I have to validate statistically by using any of the hypothesis tests that is best fit for this. Generally we use 2P test or 2T test for this. Then we'll go for the controlling and we'll plot a control chart. So control chart, again there is a major 7 types, 3 types for the continuous type of data and 8 type of the discrete type of data. And against there are 8 rules as well for the control chart, and we will validate for all 8 rules either process in my control or not. And finally in the last slide we'll add the lesson learned and we'll circulate the case study for all the people for the reference how did we achieve the target.